All right, guys, let's do a quick sound check and see how we go. Yep, I can hear myself. How are we doing? Yeah, if there's any level ones or level twos joining in, this is the big leagues, which is a level three integration two today. Um, just to kind of like recap what we were doing last, I think we were doing the 2017 paper. And I never got around to finishing the rest of the paper. So I thought we will continue with some of those questions from 2017. And like there's a few merit and excellence questions that we didn't actually do. After that, what I'll do is if you guys want to have a look at the 2016 paper, we could do that as well. Might have to run and get my dog because he's just gone out. There might be some barking that's going to happen very shortly. Harman, I sent out a post on Instagram earlier this afternoon, and I have to say, majority of the Year 11 said that they found the exams, but like a lot of them replied saying that it was actually pretty decent. Um, yeah, like there you go. Like that's what I heard. Geometry was kind of like I didn't see much of the geometry comments, but most of them said TEG was very similar to what they did last year. I guess, you know, we should have, I guess we should have kind of predicted it because, you know, originally they were supposed to change the paper, like, because I think next year they were not supposed to have level one exams, right? Did he just bark? Yeah, Ash, I think that, I had a very brief look at the paper, um, and I thought I was double checking whether I was looking at the 21 paper or 2020 paper. Yeah, that's why I was like kind of thinking about it. And I was like, well, they were not supposed to have level one exams um, next year, and I think maybe they thought they might have just recycled the paper. But geez, I've never seen that. I almost want to go and find the 2021 paper because the version I saw was like a digital copy, and I can't really talk about it. Um, but anyway, look, we're here for level three integration. And I know that we've basically got Monday and Tuesday where I'll be doing a help desk, but the Monday, Tuesday session will be slightly different for the level threes. So if there are any, like, we might just kind of open it up on Monday just to see how it goes, and then Tuesday we'll kind of keep it real simple. All right, guys. So we were working on the 2017 paper. I'm not going to record anything. I'm just going to kind of like go through. I'll probably do this whole paper again later next year sometime. But we're probably going to get started with this question here, which is a merit question. And seems like this question, like, you know, it does seem to pop up every now and then. So we might as well have a crack at this. It is a merit question. I'll leave it up here. I guess you guys need to see the time. What is it, 9:09? So maybe give you guys, it's 3E2X. I'm only going to give you guys about 2 minutes, 2.5 minutes for this. So I'll go through the answer at 9:12, yeah? I remember you panicking a little bit yesterday, Liana, but I'm glad that you feel good about the exam. Sorry, Lali, I just checked your comment now. This is 2017 integration paper 91579 schedule. Oh, Ash, is that the rectangle question at the end, right? It was like a fence. Was it a fence question? Like, did they have something like that? Like two sides, like with a plank or something like that? Uh, Gershom, Gershom, for getting achieved on integration, I would say you've got to actually answer minimum four achieved questions. And I think then you should be all right. But I always say to people, man, regardless whether you're doing level one, level two, or level three, you always got to aim for at least one merit question, because if you aim for one merit question, that's the dog. Pretty thirsty. Maybe you should actually say hello to you guys. Oh, he's really thirsty. Okay, come here. Say hello to the people. Ah, there you go. Oh, he's grumpy now. Okay, don't be grumpy. All right, he's coming to say hi to you. Okay, I'll let you go. Go. Fine, go. All right, enough. Yeah, he was pretty thirsty. Yeah, anyway, let's get to work, guys. So we've got question 1D, which we're going to be doing. This is, as I said, merit question. Who was it? Gershon. Gershon, you were actually asking, yeah, just one M from a question gets you M5. And then if you manage to get like another couple of achieved questions elsewhere, you can easily get achieved in integration, man. So looking at this question here, what we've got is we've got to integrate this to get the value of K. So are we working today? Can't actually see. Oh yeah, we are. Cool. So integral of 3e2x, and we've got between k and 0. So when we integrate 3e2x, we're going to write everything as is. But remember that with exponential integration, we've got to write everything as is. And then we're going to have to divide by the differentiation of the power. So which in this case is differentiation of the power is just 2x. So differentiate that, you're going to get 2. And we don't need to worry about the plus c because it is definite integrals, so we don't need to worry about it. So what we're going to do is we're just going to put a little square bracket around it, put it between k and 0 equals to 4. Now, Gershom, you were actually asking, what do I need to get for achieved? Guess what? This part right here is going to get you an achieved, that integration part right there. So that's what I mean by having a look at those merit questions. Because with the merit questions, integrating, like they don't give you guys complex kind of integration questions in the merit questions. It's like they keep it fairly straightforward, and then there's a follow-up question which gets you that merit. So it's a really good idea just to kind of like get your basics sorted so that when you attempt these merit questions, you just kind of end up nailing them. All right, so we're going to substitute the values. So we've got 3e 2k over 2 minus 3e 2 times 0 over 2. All of that is equal to 4. And also the other thing that I'm kind of going to mention here is like, I mean, you can, how do I say this? You can actually put this straight in the calculator if you want. If you are like kind of like worried about like I'm really nervous about working with exponentials, then what you can do is just do this and just put it directly in the calculator under your solver. So go into equation, solver, and then you should be able to kind of do that. I'm just going to show you guys quickly the other shortcut of it. So we've got 3 over 2 bracket e to the power of 2k minus e to the power of 0 is equal to 4. So rearrange this, we're going to get e to the power of 2k minus e to the power of 0 equals 4 times 2/3, which is going to be 8 over 3. I've got e 2k minus 1 equals 8/3 because e to the power of 0 is 1. E 2k equals 8 over 3 plus 1. We've got e 2k equals 11 over 3. And then 2k is equal to ln of 11 over 3, which then is going to be ln of 11 over 3 divided by 2. Now, that is a lot of working that I just went through. But let's just check the answer first, and then after that, I'll show you guys how to do it in the calculator as well, which just saves you guys a lot of time. So ln of 11 over 3 is that, divided by 2 is going to give me 6.65, which is actually going to get me the merit grade. But what I could have done is I could have just gone into my equation and put that straight in the solver. So I could have done 3 over 2 is 1.5. You know what, I'll actually do it the long method. So I've got 3 e to the power of 2k. So I'm going to put that as 2x. I mean, you can put k if you want, just use alpha k. So you click on alpha and k. That becomes e to the power of 2k divided by 2 minus 3 times shift e to the power of 2 times 0 is 0 divided by 2 equals 4. We click on that and we click on k is equal to 0. So just click on solve and you're going to get that 0.65. Cool. Yeah, I'll go through the 2/3 part, but so you can actually put that in the calculator to check your answer. How did I get 2/3? So remember that what I have is, this is what I originally had, right? 3 over 2 e to the power of 2k minus e to the power, e to the power of 2k minus e to the power of 0 is equal to 4. So I cross multiplied, so this would become 3 times e to the power of 2k minus e to the power of 0 equals 4 times 2. And then I've got e to the power of 2k minus e to the power of 0 is equal to 4 times 2 over 3. So it's just multiplying it by its reciprocal, that's all. Cool. Let me know if you guys are okay with that. And if you guys are okay with that, I can jump on to the next question. Can do another merit question. Yeah, it's just like when you divide by a number, it's just same thing as multiplying by the reciprocal. All right. Let's go. I'm going to come back to that question. We did that merit before. We've got a kinematics excellence question. And what's this merit question? All right, let's try this merit question here because this is to do with long division. Han, they are a lot more lenient in calculus. Yeah, I think I'd follow what Renee said, just round off right at the final answer. But you can go with like four decimal places as well if you wanted. This is probably a random question, but like I want to know, why does Spirit Demolisher have a gray on his chat with a little tick? What does that actually mean? Yeah, we'll do question C, guys, while you guys try and tell me what that tick actually means. But I'll give you guys, let's see, how much time should I give you guys for this one? I'm gonna give you guys about 2.5 minutes, no, 2.5, no, 3 minutes. He's verified. Oh, there we go. I learned something new today. Nice. I just had a quick look at your channel, Spirit Demolisher. It's pretty cool, man. I gotta ask, Spirit Demolisher, did you get like a little 100K trophy from YouTube? Which one are we doing? Question C. Yeah, you're on the money there, all the possibilities. Huh, nice, man. That's pretty cool. All right, guys, we've got another 10 seconds and I'm going to go through this answer. All the possibilities, yes, you do. Without correct solution, with correct integration is going to get you a merit. If you don't do anything, if you don't show any kind of integration, then you're going to get no grade for that, unfortunately. Cool. Now, which way, oh man, you might be all right. Okay. Now, which way do we actually want to do this? Do we want to actually, do you guys want me to show you guys the long division method, or do you guys want me to show you guys the substitution method? Which one do we want to go with? Because I know that the long division, like some people actually do synthetic division, I think it is. I've never done synthetic division. Like I've had a look at it a couple of times. But we'll do long division first because in this case, the long division kind of like works out quite nicely. Synthetic, I don't know, like, yeah, I need to actually do that, but substitution we'll have a look at as well. So this is like, just remember, we are not even integrating it yet. So the first part is actually trying to break this equation down, right? So because we got x plus 2 and 15x minus 15, I'm just going to write long division like this. And I'm sure other people might have like different shortcuts. So if you do have, yes, you can use synthetic division if you know how to use it, Gershon. Unfortunately, I can't, I don't think I've ever used it. So I won't actually be able to help you out with it because I find long division easy for me. So the way I do it is I look at the coefficient of x here, which is 15. So I'm going to put a 15 on top, which means I'm going to get 15x plus 30. Really weird, like it's I'm getting like, oh yeah, 45 over that. Yeah, that makes sense. And then after that, what I'm going to do is I'm just going to subtract 15x. I'm going to put a minus, and I'm going to put a minus here because I've got to minus the black 15x plus 30 from the blue 15x minus 15, which means 15x minus 15x is 0. Negative 15 minus 30 is going to be negative 45. All right. So once we get this, what we're going to do is we're going to rewrite 15x minus 15 over x plus 2 as, which is equal to 15, and what do we have? Minus 45 over x plus 2. So just to give you guys where all these numbers are coming from, you have the quotient here, that's the 15. You have the remainder, which is minus 45, which is going to end up here. And then you've got the divisor, which is going to end up being here. So with this particular question, long division is like very easy because it's just like one line and you're pretty much good to go after that. Because once we get this part right, because then all we have is integral between 11 and 1. We've got 15, take away 45 over x plus 2, which means when I integrate it, I'm going to get 15x minus 45 ln of x plus 2, and that's between 11 and 1. So it's just a matter of substituting then. I've got 15 times 11 minus 45 ln of 11 plus 2 minus 15 times 1 minus 45 ln of 1 plus 2. Again, like I wouldn't actually do all of this in the calculator, but I would write it down like this. But then I am going to be very cheeky and just go straight into my calculator and just put the original integral function in there. So, which means I'm going to go into option, calc, integral. I'm going to write the equation down, which is I've got 15x minus 15, and that's divided by x plus 2. And I'm looking for between 1 and 11. So that's 84.01. So how did I get that 15? Because remember that I've got x plus 2 here, and I've got 15x minus 15. So I actually need to get rid of this 15x. I need to actually get rid of the 15x. So I need to multiply this x with this number at the top here, which is going to give me 15x here. So that's why I multiply by 15. So 15 times x equals 15x. Oh, this is a merit question. Like, I would actually say this is a, you know, Gershon, you were looking at it before. Like this is probably one of the merit questions you want to try and aim for, because there's your 2 merit questions. You got 10 points. You're done, mate. Got you achieved. You might as well go for that other merit day. Like you only need 1 more merit question and you can get a easy merit there. Because 15 points is going to get you guys a merit. Is that all right, Kevin? Oh, no worries, Spirit Demolisher. I think I just kind of, I'll just let it go, man. This is like a hobby for me. I think my important thing is like the things I get to do at school. That's a lot more fun. This is just to keep, you know, help out people as much as I can. The weird thing is like I've kind of been every year I say bye to a whole bunch of year 13s, which is really kind of neat. Some year 13s stay back because they always come back to like other live streams and just kind of tell the new year 11s, new year 12s what life is like at uni. So it's pretty cool. So how many marks is that question in that, and how many more needed for merit? Hamza, you need 3 merit questions to get 15 points, which gives you a full merit in the paper. So we've just done 2 merit questions. That's 10 points already. Now you guys wanted to know about substitution. Very quickly, I'm going to show you guys substitution. I'm not going to, what do I call it? I'm not going to, well, we could do it. So that was between 11 and 1, right? So what you do is you actually do something like this. You put u is equal to x plus 2. And because u equals to x plus 2, we can say that du dx is equal to 1. That's all fine. The other thing that you need to do is you kind of need to write x by itself. So what you're going to do is you're going to rewrite this as u minus 2 equals to x. And the reason is because the u, which is x plus 2, you can actually substitute it here. But because we now have x is equal to u minus 2, we're going to get rid of that x where it says 15x minus 15. And also one other thing is, because du dx is equal to 1, we can actually say that du equals to dx. So this part here, we're going to have to replace the dx with du. So when we rewrite this, we're going to write it, and we're not going to write the 11 and 1 yet, but I'll show you guys how to do it the other way. So we're going to get 15 u minus 2 uh, minus 15 divided by u. Now dx is changed to du, but we still need to change the 11 and 1. So remember, x is equal to 11 and x is equal to 1. Now we said that u is equal to x plus 2. Because of that, u is equal to 13 and u limit is going to be 3. So we're going to change this to 13 and 3 because now we have everything in u. So we expand the numerator, we're going to get 15u minus 30 minus 15 divided by u. We're going to get 15u minus 45 divided by u. Again, all of this is between 13 and 3. Now we can separate the two, we can separate the denominator. We're going to get 15u divided by u minus 45 divided by u. All of this still between 13 and 3 du. 15u, the u's cancel out. We've got 15 minus 45 over u, which is 13 and 3. Now what you guys will notice is now when you integrate it, you're going to get 15u minus 45 ln of u, and that's between 13 and 3. And you can kind of see that's pretty much what we got in the other version as well, except we got it with like x with 11 and 1. I need to have a look at that question trumped up. But yeah, are you guys okay with this question with the substitution? Like, look, substitution, I know a lot of teachers kind of say like it's out of fashion. Um, I absolutely enjoy substitution because everything kind of like works out really beautifully. You don't get to miss out on like little things. Um, Long division is definitely useful as well because like sometimes some questions you might be better off doing long division. And because long division also comes in handy with complex numbers, I would say keep that in your like make sure you kind of know how to do the long division part as well, so that it helps you with complex numbers. Sometimes you get some really awkward questions where long division might be actually more better for you guys. All right, so that was question C. Let's go to another merit question, and then after that we'll do an excellence question. Um, and again, this is another one of my favorite merit questions, differential equations, which ends up being, which ends up being like, pops up most of the time as a merit question. It's a common question that pops up. So again, I'm going to give you guys like 3 to 4 minutes to kind of have a go at it. And then we'll go through the answer. And with the answer, you guys don't need to actually solve it. You can actually leave it in the exponential format if you want. Ah, Liana, you're back. I can't even remember now. Are you in level 2 or level 3? Because, man, I remember you asking me level 1 questions. God, is it 3 years already? Jesus. 2 years. Yeah, I remember, like, Jono has been asking me questions like from year 11. I remember that name so well. It'd be nice when you come back in a couple of years, Jonathan, and just give some advice to some of these year 11s. Yeah, definitely. It's kind of weird because it's like I don't like I think it happened it It happened once when I went to Melbourne. Actually, no, I was going to Melbourne, and there was a guy that at the customs, and he actually recognized my voice, and he actually asked me, "Are you Infinity Plus One?" And I'm like, "Yeah, yeah, I am." And it's quite funny when I start meeting you people, and I don't even know who you are, but you kind of recognize my voice and kind of go, "Oh yeah, that's the guy that does the maths stuff." Let me have a look. That's interesting. I would actually say you would need to make it y, all the possibilities, um, because generally with differential equation, when your final answer has to be in y. But I looked at the answer schedule. They do accept ln of y form. So you can actually leave your final answer as ln of y as well. I vaguely remember you, yay. All right, guys, another 50 seconds and I'll go through this answer, all right? Gershom, you were wondering, what do I need to do to get it achieved? If you get a question like this with differential equations, make sure you know how to do them, man, because there's only one thing you got to do with this question, and then it's some of the most easiest integration questions you're going to get. So make sure you keep an eye on this one, this question. I think every year I've seen this question pop up, like as a merit. Just going to have a look at the integration from 2020. Did it come in 2020 as a DE? Yep, yep. 2020 question 2D popped up as merit question. All right, guys. So let's actually go through this question here. So with differential equations, all right, they always give you this dy dx equals y over something, or some letters in that other side. Your first step is this. What you want to do is you want to take dx to the other side, and so basically the idea is that you take all the x's to the other side and all the y's to the other side, and then after that we start integrating. Han, after this question, I'll explain that. All right. So here, what we're going to do is we're going to have dy over y equals, it's going to be cross multiplied, so it's going to be dx over square root of x. Now, while some people actually get confused with this, the reality is all we're really facing here is 1 over y dy equals 1 over root x dx. That's all the question is actually showing. All right. So basically, we're going to integrate both sides. So on the left-hand side is nice and simple because we're going to get ln of y. And I'll tell you guys this right now. I think majority of the time, you're going to get ln of y because they're going to have y on the numerator. On the odd occasion, you'll have to factorize before you move the y. And I'll show you guys after this question finishes the other variation with this. So that's ln of y. And then here we've got 1 over root x. So remember that 1 over root x is, I'm not going to integrate it yet. I'm going to rewrite it first. This is the same as x to the power of negative half dx. So I've not actually integrated it. Okay. I've integrated the left-hand side, but not the right-hand side. Now I'm going to add 1 to the power. So negative half plus 1, that's going to be positive half. I'm going to divide by the new power, which is negative half plus 1. And of course, you have to put the plus c for this. All right. Without the c, you're not going to go anywhere in this question. And that's really, really important. Because once you put that c, you're going to get your achieved grade there. And then we're going to go on to the merit part of it. So what we've got here is ln of y is equal to x to the power of negative half plus 1 is just positive half. And that's positive half plus c. When you divide by a half, it's the same thing as saying 2x to the power of half plus c. We need to figure out what c is. We've been given the values. I'm going to maybe try a different one. So x equals to 4, y is equal to 1. So x is equal to 4, y is equal to 1. Just kind of saying that what I've got here is ln of 1 equals 2 times 4 to the power of half plus c. ln of 1 is 0. 4 to the power of half is 2. 2 times 2 is 2. 2 plus c. So we can say that c equals negative 2. So we can say ln of y equals 2x to the power of half minus 2. Why do I have minus 2? There's something not right here. That should be 4. You're right. Sorry. That should be 4. My bad. And then you could leave your answer like this, or you could just put everything with exponential power, which means we're going to get, yep, thank you, Real Gamers, got that. And that's it. So that's your merit grade right there. So I am going to find a little trick question for you guys. Very similar, but they kind of put like where you have to factorize first. And that pretty much trips up people, right? Because they see like 2 y's and then they go, oh, right, how do you do this thing? So give me a quick second. I'm just going to have a quick chat. Like, what was it? Han wanted to know this. So let me just share the screen here, Han, and then we'll talk you through that quickly. Where are we at? Wrong camera. Maybe that one. No, the other one. Integration OneNote. What has that got? No, that's the wrong one. Give me a second, guys. Just trying to find the screen. NCEA level 3 calculus. Here we go. All right, let's have a look. Han, here's your cut score right there. So, as I said to you guys, oh, look at that. Guaranteed merit is like answering 3 merit questions is going to give you 15 points, which means you're like almost, yeah, for this paper, it's like easy merit right there. So how it works is like if you answer 2 achieved questions, 2 achieved questions is going to get you like 3 points, but 1 merit question is going to get you like 5 points. You answer an excellence question fully correctly, that's going to give you 8 points. So that's what that 8 points means. So maximum you can get from each question is 8 points. If you get all 3 questions with 8 points, you're looking at 24. But like I said, my minimum benchmark for people that I work with, that's including you guys, I keep pushing you guys, is you want to try and aim for like an M5 in each question, which gives you 15 points, which is like guaranteed merit. Yeah, you should be good to go. Spirit Demolisher, the reason why we put C to the X side, you could put it to the Y side as well. But remember, when you actually put constants on both sides, when you add the 2 C's together, you're still going to get a constant. So therefore, that's why we don't really bother with when we're integrating both sides. As long as we put C on one side, then it's all good. Because you're still going to end up with like 2 constants, so it doesn't really matter. Yes, Zubair, I have had a student that's actually attempted all excellence questions back in 2014 and just, you know, he finished his questions in like all 3 papers in like 2 hours just doing the excellence questions. Very risky, but what he did do was like he then went and did all his merit questions and then had time, so he actually did all the achieved questions as well. Yeah, I'm not sure about that, Aliana, if they actually do that. Like it's highly risky. I mean, like you got to be like, see, that's why I say to you guys, like, you know, when you guys go and have a look at exam papers, if you find like proof questions, you know how they say like prove this is equal to this and blah blah blah. That's like a that's like basically they give you the answer and then they're asking you guys to actually prove prove your answer, right? So you know that if you spend like 10 minutes on that question and if you can get to that final answer, you know you're guaranteed 8 points. So you don't actually have to worry about those previous questions. So keep that in mind, all right? If you see a proof question, you got to go, okay, this is a proof question. Can I do this proof question and get like 8 points, which means I don't have to do those achieved and merit questions. That's like a nice little strategy to have. Yeah, Emma, that's a bit unfortunate, but like I said, that's when you got to strategize and go which question you're not feeling confident with. So you go back and do those merit ones so that you cover your bases that way. Because if you got an E7, E8, and an M5, or not an an M5 or an M6, you would have got an excellence for that paper, Emma. So keep that in mind, eh? All right, let's go. What's the next question we're doing? The other one that I was going to show you guys was this one. Sometimes the differential equations, they will mix it up like this. I'm trying to think. Oh, yeah, here we go. So let's say there's a differential equation. I'm going to put an example here. And I'm going to say that x is equal to 1, y is equal to, I don't know, 6. Yeah, I'm going to leave that question for you guys to try and have a go at it. Deku Goose, I'm coming back on Monday and Tuesday for you guys for my final 2 sessions of the year. My wife is extremely happy that it's the last 2 sessions and we can actually going back to watching some TV shows and movies in the nighttime instead of me sitting in front of my PC. I'm going to give you guys one clue, and that's basically it. This question, I've seen people kind of like mess around with it. Yeah, sorry, Gershom, I'm doing it on Sunday night and Monday night, not Tuesday. How are we going, team? How are we going? Okay, here's the hint for you guys. This right here is where people end up making the mistake. Um, it is understanding that you've actually got a common factor there. Because it's a common factor, you actually need to write this as y um, 3 plus x. Now retiring for the year, man, for the year. I'm sure the year 11s are going to come back next year and they'll be like, level twos, we're at level 2, let's do tutorials, please. And then the whole cycle starts again. So now we've separated with y and 3 plus x. This is what happens. So in this case, we're going to get ln of y equals 3x plus x squared over 2 plus c. All right, I'm not going to carry on with the rest of that question, guys, because then it's just a matter of just substituting x equals to 1, y equals to 6, and kind of figuring out c and the usual shebang. All right. Yeah, like there has to be because like it doesn't work with like yeah, differential equations, it doesn't work with like just y on its own, like unless they already give you guys y on the left-hand side. And if they don't give it to you on the left-hand side, then you've got to kind of rearrange it somehow, and it always ends up being like ln of y. Cool. We're gonna do a kinematics questions, guys, because I know that it just keeps coming back. Where was it? Here we go. This is possibly one of my most favorite type of integration question because it is the most frustrating part to actually go from acceleration to velocity. Because if you can actually go from acceleration to velocity in this question, then you're pretty much sorted. Because the whole question is pretty straightforward, right? The only trick part is the actual acceleration part. So I am going to leave this question up for you guys for maybe about just 3 minutes. And I'm not looking for the final answer. All I'm looking for is just the velocity function. And then after that, I'll give you guys some more time to actually work through it. But put up what you think the velocity function is. And let's see how you guys go with that, because I tell you, this is the trickiest part. And by the way, this question is actually uh, does pop up in your Delta exercise book, that big book that you guys have for calculus. I have seen this question there. So I'll give you guys another 2 minutes to have a go at it. Substitution is going to help. I will tell you that right now. And I'm going to put a hint here for substitution. If you don't want to look, don't look at the screen. I'm going to rub it off very soon. So here comes the hint. If don't look. Okay, that's the hint for substitution. Jonathan, you don't necessarily need it, but having it in your having it in the back of your hand is like really good, man, because it helps you with these types of questions. Because it's really hard to see some people can see the reverse chain rule in this straight away, and some people will kind of find it a bit challenging. Um, and I'll kind of show you guys how it actually goes about this question. I'll give you guys another minute to have a play around with it. You can do reverse chain rule as well, by the way. No worries, Ben. You're welcome, man. It's not a problem. Yeah, there we go. Nice, nice. Got it. Got it there. It's a beautiful equation. Keep going. I think keep going with that question. Let's see, let's see, let's see. Yep. That's exactly what we do, Gershon. So it's not as yeah, it's just fine. It's the integration part that's the tricky part. I think once you get the integration part, this is possibly one of the easiest excellence question that you're going to get for kinematics. Nice. I think what are we looking at the answer for this 2D, 2E? Yeah, I'm curious to see what your guys' answer is. You guys should be getting around 45.8 by the looks of it. All right, guys. So I'm gonna go through just the velocity part just to show you guys. I'm gonna show you guys both methods, um, just so that you can kind of see substitution and you can also see reverse chain rule. Um, like I said, the reason I kind of stay, I mean, like the reason I don't spend too much time with reverse chain rule is because for you to get good at reverse chain rule, you should have done a lot of differentiation. Like if you're super confident with differentiation, then you can kind of like see reverse chain rule fairly quickly. Now, in this case, all right, in this case, particularly with the ln of t and 1 of t, what we've got is no idea about we edits. I'm just kind of going, and at some point I'm probably going to crash because I do have to got school tomorrow. But yeah, we'll probably do one more question, one more excellence question after this, and then we'll probably wrap it up. We'll go a bit longer on Sunday, guys. Like we'll probably go for like maybe a couple of hours. Like I'll check in with management and then see if we can go for like a couple of hours, and then but Monday night we probably won't go for too long because I don't want you guys to be like staying up on Monday night before the exam. Just yeah, it just gets a bit too stressful. But Sunday I'm happy to kind of go a little bit. Yeah, just sit around and do some questions. Anyway, we're gonna do this. So we've got A of t is 20 ln of t, and there's only one thing that I'm gonna do. I'm gonna see. I guess it's kind of like understanding. Like when I see this, I'm like, how the hell are you supposed to integrate ln of t? Because there's no way you can integrate ln of t, and I think that's your first clue that you're actually doing reverse chain rule. The other clue is the 1 over t. So if you think about it, this is actually 1 over t. All right. So the connection you have to make for reverse chain rule is that when you differentiate ln of t, you're actually going to get 1 over t. So if you can make that connection, then what you could actually do is, yeah, then it just becomes like, integrate with chain rule. So I'll do that one real quickly. So the way that works is like I can see that if I differentiate ln of t, I'm going to get 1 over t. So I'm going to write 20 ln of t, and I'm going to put that as squared divided by 2, which is the new power. And I've got that multiplied by 1 over t. But remember that with reverse chain rule, you also have to divide by the differentiation of ln of t, which means I have to multiply by the differentiation of ln of t, which is 1 over t. So basically what's happened here, don't forget the plus c, by the way. Basically what's happened here is the 1 over t and the 1 over t cancels out. And 20 divided by 2 is 10. So we're basically going to get 10 ln of t squared plus c. Now this is your velocity function. All right, now I'm happy to kind of go through that again. Like chain rule, when you think about chain rule, right? Like you'd go, like normal chain rule is when you do something like this. So you go x plus 3 cubed, you'd go 3, x plus 3 squared, maybe let's put this as x squared, multiplied by 2x, which is the differentiation of the bracket. All right, that's like in differentiation, that's the normal chain rule. Reverse chain rule is pretty much doing the same thing, but except you're doing it backwards. So you increase the power by 1, divide by the new power, and also divide by the differentiation of whatever's inside the bracket. So yeah, I mean, like it's just like you kind of have to do enough of the differentiation problems to pick up the reverse chain rule. Oh, no worries, Rainbow. Good luck. Good luck with your rest of your exams, mate. Glad I could help. Now, if you were to do substitution, this is how it worked with substitution, all right? So we've got 20 ln of t over t. So here's how you do substitution. Watch this one. This is not too bad. I know people always go, oh, substitution is too hard, but yeah. I put down u is equal to ln of t, which means du dt is equal to 1 over t, which means du is equal to 1 over t dt. And that's it, I'm done. Because look what happens. I can put u is as ln of t, and then I've got 1 over t dt, which is basically this whole thing is 1 over t dt. So I can replace this with just 20u du. Then if I integrate this, I'm going to get 20u squared over 2 plus c, which is 10u squared plus c. And because u is equal to ln of t, I can replace that with ln of t squared plus c. And guess what? Got the same equations there. All right, so that's one of the main reasons why I pretty much love working through substitution. No worries, Zazie, you're welcome, man. I guess I'm sitting with you for the next 2 years. It's all good. This is how this rolls. So as you guys can see, two different ways of doing this. One is through substitution and one is through reverse chain rule. Pick the one you want to work with, man. Like whichever one you find comfortable, just go with that, and then you're pretty much done with this question, because then you're just going to substitute the what is it? Velocity is 12, t is equal to 4. Find out what the c value is, and then just substitute 10 seconds. So just put in as what t is equal to 10, and figure out what the velocity is, because that's going to get you an excellence right there. So that's all good. So did you guys want me to carry on with this question, or what are we doing here? Let me know. One more example with the reverse chain rule. I need to find the question, guys. Okay, I'll quickly carry on with this question just to show you guys. So we've actually got, what do we go? So we've got velocity is equal to 12 and t is equal to 4. So we're going to substitute that in. So we're going to get 12 is equal to 10 ln of 4 squared plus c. And you know what? I'm going to be super lazy with this, and I'm just going to do this. I'm going to write down 12 minus 10 ln of 4. Let's just do that again. 10 ln of 4 squared is equal to c. No worries, real gamer. Catch you later, man. Because the reason I want to do this was because then I could just straight away go velocity of 10 is equal to 10 ln of t squared. Remember, this was plus c, right? But because we figured out what plus c was, which is plus 12 minus 10 ln of 4 squared. So I'm just trying to kind of like not write it in decimals. Then I can say v of 10 is equal to 10 ln of 10 squared plus 12 minus 10 ln of 4 squared, which I think I did see someone actually put that answer up there. So yeah, if you actually work it out, you should get 45.8. Let's just kind of do that quickly. So what do we got? 10 times ln of 10 squared plus 12 minus 10 times ln of 4 squared. Yep, there we go, 45.8. And that's going to get you that excellence grade rate. For C, can we make it just a single number, or does it have to be the whole thing there? Gershom, as I said, you could put that as, you could calculate it, which means I think that comes out to be negative 7.218 or something like that. That's going to get you a that's going to get you, correct integration is going to get you a merit. So that's up to here is going to get you a merit. Deku, with the reverse chain rule, because I know that I'm going to cancel the 1 over t, so that's why I don't actually integrate the 1 over t, and that's the whole. That's why I said to you, like with a reverse chain rule, you gotta do a lot of practice before you can kind of understand. Oh yeah, that's going to get canceled out. That's why I don't need to worry about integrating that 1 over t. Yeah, which is why I kind of like, I keep talking to people about substitution, but you know, and I know that, I think from what I heard from one of my colleagues is that people don't actually teach substitution rule anymore, but yeah, it is still fairly useful to go with. That was a yes, Gershom. So you could actually just leave it as a single number. So you could leave it as negative 7.218 instead of writing that whole thing. But the reason I left it as a whole thing was because I'm going to do the calculation anyway. So I just kind of kept writing it. So you could have left it as 7.218 and you're still going to end up with the same answer. If you did integrate it, would it still work? No, it won't work. Because I'm integrated with the reverse chain rule, I'm always looking to cancel something. So here's a good example of reverse chain rule. Like something like this. Try this question for a reverse chain rule. Might as well make it into a merit question for you guys. Uh, let's see, what do we do? Between k and 0, we're going to go cos x equals to 0.5. Yeah, let's try that one. There you go. That's a merit question. That's going to get you to do reverse chain rule. And you are also trying to find between k and 0. Carbon units is, I don't think they talk about any units. Generally speaking, they don't stress too much about units. But yeah, meters per second, you could actually chuck it up there as well. Dibble. Why does that name sound familiar? Zazie, where are you from, Zazie? You from Auckland or Wellington? No, not to be safe. I think for this question, you can see that the velocity is meters per second because they actually say that right there, 12 meters per second. So we can just go meters per second for that one. Oh, yeah. It was back in April, man. I think we talked about it last time we were doing this question. No, not yoke. For the other question, you don't need to go unit squared. If they ask you area, you can just leave it as area, like just a number. You don't need to worry about unit squared. Yeah, say hi to him, Zazie. It's always nice to meet people on the road. How are you guys going with this one? Yep, nice, Jonathan. That's a good starting point right there. I don't know if this is actually going to work, but don't forget, yeah, you don't need the C for this because this is actually definite integrals. Uh, what do you guys want me to sit in like a mall or something and sign calculators? Crying out loud, man. I don't know what you're on about, easy. Tom, I teach at Ormiston Junior College, man. It's like I was showing the year 11s and 12s what I've been doing for the last, I think yesterday. I'll show you guys what I did yesterday with my year. This is the class that I teach, all right? And where is it? Here we go. Where's my Zoom lessons? Here we go. Zoom lessons. Yeah, this was my class 2 days ago. Look at that stuff. Look at how pretty that is. Back when life was so good, wasn't it? This is what I teach. And the maximum I go to is like, here we go. Look at all of this, two-step equations. Oh, remember this part here? Remember this? I think you guys would remember this. There you go. Way back in the day. Oh, glad to help, Luca. Not a problem, man. It gets boring, Raymond, after a while, because it's like I enjoy the stuff, but I don't enjoy the marking. I don't enjoy the internals. I don't enjoy the stress of it. So, which is why I can kind of do the things that I want to do in the night times and still do all this, keep up with all the calculus stuff. And at school, I tend to do more on the tech side of things. So just kind of have fun with the makerspace that I have. Sorry, Yoke. Sorry, apologies. Kind of got distracted. Yeah. Let's do this one. Yeah. So reverse chain rule. the reason why I know that this reverse chain rule is because I know that when you differentiate sine x, you're actually going to get cos x. So that is, is my computer frozen? There we go. Let's try that again. See, this is what happens if I don't do things quick enough. There we go. We're back in business. So as I said, I know that when I differentiate sine x, that I'm going to actually get cos x, right? So that's my little clue that I'm actually doing reverse chain rule. So here I'm going to rewrite this one more step, and I'm going to rewrite it like this. I'm going to have sine x to the power of 3 dx. So when if I use reverse chain rule, then this is going to become sine x to the power of 4 divided by the new power, which is 4. And I also have to divide by the differentiation of sine x, which is cos x. And because I do that, what happens is both of those cos x disappear. And what I'm left with is sine x to the power of 4 divided by 4 is what I'm going to get as my integral. And because I'm doing it between k and 0, that's going to be between k and 0. So I've got sine k to the power of 4 over 4 minus sine 0 to the power of 4 over 4 is equal to 0.5. Sine 0 is 0, don't have to worry about it. I've got sine k to the power of 4 over 4 equals 0.5. That's actually just gone as sine k. It should be sine k. Yep, sine k to the power of 4 is equal to 4 times 0.5 is 2. Sine k is equal to 2 to the power of a quarter. And then k is equal to shift sign negative 2 quarters. And I tell you what, I think I might have stuffed up this question. But let's see if this actually is going to work out or not. I get a feeling I've stuffed this up. Shift sign of 2.25. Yep, I stuffed it up. Sorry. Yeah, it just I made a random question, guys. Apologies about it. I think it wouldn't work for 0.5. Maybe I should have gone a little bit smaller than that. Maybe I should have gone at 0.05. Let's change that, all right? What if we do it 0.05? This is what happens when you come up with questions on the spot. Yeah, I'm going to change it to 0.05, which means I'm going to get, hopefully this works out. That'll be 0.2, 0.2, 0.2. Let's try this one. 0.2 to the power of quarter. There we go. That's much better. So we can say that k is equal to 0.73. Am I going to do differentiation in complex papers? I think I've already done them, Paul, just been doing them really slowly. But maybe on Sunday we do a marathon. We do a marathon session on like just like 3 papers from 2016 or something like that and just go smash it out. Sahil, I keep saying every year that I'm going to quit towards the end of the November season because I'm like just exhausted from daily tutorials. But then by August, what happens is like all the MCAT kids come and then they're like, oh, please help us with MCAT. And then I start doing MCAT and then the level 2s come, oh, you're doing MCAT, let's do level 2. Then the level 3s come. So most likely I'll do it for another few more years. Yeah, guys, I didn't realize the time. It's 10:15. I gotta get some shut eye, man. So what we'll do is like I said, just keep an eye on it. I just need to confirm, just trying to figure out what time we can actually start on Sunday, and maybe we just do like all merit questions on Sunday from 2016. All papers, like all complex integration and differentiation. We'll probably just kind of like try and smash it through. Um, and then, yeah, and then we'll see how it goes. Yeah, Khan Academy. That's the whole reason why I started this was because I didn't like what Khan Academy had. Good luck with that, Yeezy. Good luck. Yeah, that's us today, guys. I think we all need a break. We'll see how we go to on like what is it? Friday, Saturday. She's working early morning, so we'll see how we go. Otherwise, you guys have a good one, and then I will catch you guys on Sunday. But just keep an eye on Instagram or even on the channel. We might start a little bit early so that we can actually get through some of those older papers. But just really trying to, I'll probably do a lot of merit questions, just so that you guys are pretty much confident going with like at least you know that if you kind of do halfway through that merit question, you can get a couple of points from it. Uh, and merit, I think you only need 13 or 14. So if you get like three merit questions, you're like at a solid merit. And I even say this to people, if you start aiming for those merit questions, and if you just manage to get like one E7 or an E8, you get very close to that magic number of 20, 21. So yeah, I'm gonna be here, Zubair. I'm not going anywhere. I'm like, I'll try and catch up to Spirit Demolisher's numbers, but I don't think that's gonna happen anytime. I think I'm projected. I think what was it? One of my student said that, sir, you're projected to reach 100K sometime in 2025, I think he said. And I'm like, oh yeah, I don't think that's gonna work because like most kids kind of unsubscribe after they finish with it. I'm like, he's like, no, 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 so you're gonna go. I'm like, yeah, whatever. I'll see what happens. Oh yeah, of course I remember you, Ziyash. Jeez, man, how many questions did I answer at level two for you? Oh, it's awesome to hear, mate, that you finished your first year of engineering. That's really cool. It's almost like I need to have like a reunion stream of like people that have actually been and done something else. That's really cool, man. Really cool for you to pop in and just say hi to us. I really appreciate it. Yep, that is, yeah, it is what it is, eh? Biomed, jeez. Why do we even do that stuff to ourselves? What's our next exam, guys? What is our next exam for tomorrow on NCEA, or is it actually no exams tomorrow? Nah, Leon, we got two more, man. Jeez, stick with the program, dude. We got a Sunday marathon coming up, and then we'll do Monday one will probably be a bit more relaxed because like I probably won't be doing many questions, just kind of like guiding people here and there with like tips. So what do I got scheduled for Sunday at the moment? I think I put you guys down for 8 o'clock, but yeah, we'll try Zubair. We'll try do all three merit, all of the. So what? That's about 18 merit questions. So if we do five, 10 minutes each, no, 10 minutes each is too much. 5 minutes each for those merit questions, we're probably looking at a 90-minute session for all the merit questions. We'll see. I think that's what we'll aim for. So I think I've scheduled you guys down for 8 p.m. But I'm thinking, yeah, I'll check with my management what time he goes to sleep and what time he wants me to read his book, and then after that we're good to go. Depends, Jonathan. Like I look, honestly, man, I would actually say pick your easiest, what you feel really confident in. I actually tell my like back when I was teaching calculus like a few years ago, I used to tell my students like read all the like all three papers, mark all the questions that you can do like real quickly, and the one that you need a bit more time, and the one like you got no idea. Then I told them like just go do all the easy questions with all the papers first. So get that out of your system. Um, Otherwise, what happens is you tend to start putting pressure on yourself as you get more closer to that after that halfway point. Your brain starts kind of starts yeah, you start panicking a little bit, and your thinking is different. So really important that like you kind of get them, you manage your time as well on, especially for those guys that are doing like 3 exam papers. You really got to keep an eye on the clock and go, yep, this question I'm only going to spend 20 minutes and I'm going to move on after that, because it's yeah, it's so much more important with the time management for the exam. I don't know what the answer to that question is, Deku, because seriously, like I'm so out of it. Juan, it depends, man. Like if you're really confident with the like I said, if you see like proof questions, you know how in complex numbers they say like, oh, if this is an imagined number, prove that this question is this, blah blah blah, whatever. Those ones I'd say like, I would say if you're confident and you're like, yeah, actually I know how to do this and I can prove this question, then yeah, go for it. But again, I would keep an eye on the clock, because you get 20 minutes per question, which means after 8 minutes, you haven't actually solved that question. That's when you go, okay, maybe I need to go and make sure I do the 2 merit questions so I can at least get 6 points from this paper, from this one question. I don't know, but yeah, no. Anyway, guys, yeah, that's the one, Lou, that I'm talking about. Like, if it asks prove it's purely imaginary or make real part equals to zero, vice versa, those types of questions, yeah. Those ones I'll be like, man, I'd go straight at them. If I see that question, I'll be like, in my mental head, I'll be like, okay, this is the question I need to attack first. Because if I can finish an excellence question in the first 10 minutes, that 10 minutes extra is going to go to another question. William, I'm just joking around, man. Like towards the end of every year, I like, I get so tired, staying up every night doing tutorials for like multiple people. And then after I finish tutorials, I spend like another probably like half an hour answering questions on like Instagram and comments. And like every year I'm like, nah, this is it. I'm not doing this anymore. I'll even show you this. Hang on, let me show you guys this. This is what I posted in our teachers page, and I'll show you what. Where is it? Let me share that with you guys if I can find it. Where is it? This one? Yeah, here we go. Like, this was like a month ago. Every year, I think this is the last one, but here we go again. So yeah, definitely, probably will be. It's a cycle. It's a stupid cycle that I'm stuck on. I can't get out of it. There's already been, Cameron, like this link. I'll post the link, dude. Like, so if you go to my website, right, like right there in the front, all the last 1 month of tutorial schedules are there. And if you go to the playlist, there's heaps of playlists that you can. All my work is up there on the channel. So under level 3 calculus exams and revisions, they're all up there. Go have a look. Yeah, Lou, I remember one of my first videos in 2015 had like 10,000 views, and I was like, "Whoa, this is crazy!" But at that time, that was the only MCAT video available for kids to watch. And then after that, it kind of just started getting like heaps of things. Jonathan, I got a Surface 7 recently from Microsoft Australia, which I keep forgetting to thank. Don't worry, Nolene, I'll put up a post. Thank you for that. But yeah. 2020. That's me, guys. Have a good night. Sunday, keep an eye out on for the chats. Chats, what I'm talking about. Keep an eye out on Instagram, and then, like I said, we'll do a merit question marathon on Sunday, and then we'll see what we can do with the excellence questions later on in the night. All right. Have a good one. Good luck with if you guys have any exams from now. Well, I don't know if you guys have exams tomorrow or not, but good night and see you guys Sunday. Catch you guys.